So with 4.4 day 2, we're going to solve systems with elimination. Elimination is just another way to solve systems. Sometimes substitution works better and sometimes elimination works better depending on the problem. And so it's good to have both in our pocket. On your test, you will be asked specifically, solve this by substitution, and then specifically solve this by elimination. And then you might be given one that says solve with either. And so you can decide which one you would rather do, which one you're more comfortable with.
Which one is easier?
It depends on the problem.
Okay. And what was the one we did? Yes.
Substitution. And so it also depends on the person too. Like some people might feel like elimination is easier and some people might feel like substitution is easier. So they might have a favorite. So the steps for elimination are kind of confusing, just like the ones for substitution. So we're going to write them down and then we're going to talk about them as we do a problem. So the first step for solving a system by elimination is to identify which variable has the same coefficient with the opposite sign. Same coefficient, opposite sign. Does anyone remember what coefficient means or what it is?
Opposite or the same?
Hmm?
No. What?
Coefficient. The number in front of the variable. So coefficient is the number in front of the variable. And so that'll be important to remember because we will be using that to help us decide what way we want to eliminate. Okay. Sometimes there won't be a variable with the same coefficient with an opposite sign. So if there isn't one, we will manipulate.
Wait, isn't one meaning coefficient?
Isn't one meaning same coefficient with opposite sign. So meaning same number, opposite sign. So you might have 4x and negative 4x or 7y and negative 7y. Does that make sense? And so if there isn't one, we will manipulate with multiplication. To make one. We will manipulate with multiplication to make one. Then we will add the equations to eliminate that variable. We will solve, and then we will substitute to find the other variable. Like I said, these are the steps. They make more sense when we actually do it coinciding a problem. That last step, when we substitute to find the other variable, we will use an original equation. The last part of it is exactly like what we did last class. It's just the first part that's different. Let's start with number 1. So let's look at number 1. So we are going to look for variables that have the same coefficient but opposite sign. So if you look at the first one, we have a 1x, a 1y, a 1x, and a negative 1y. So all of the variables have the same coefficient, right? It's 1, 1, 1, negative 1. But we're also looking for that opposite sign, which we also have with the y's. We don't have it with the x's, do we? Only with the y's. So seeing that, we are going to cancel the y's. So what we're going to do is we're going to basically make this stack of equations look like a problem, like an addition problem.
So 2x equals 16.
Mm-hmm. And so we cancel the y's, we add the x's, so x plus x is 2x. And then we add the numbers, so 14 plus 2 is 16, like that.
So you just make it one place.
So we add everything vertically, kind of like when we would add like multiple digits. Like if we added like 372 plus 468.
What do you do with the y's?
They canceled. It was a positive y and a negative y, so they cancel each other out. And then we have an x plus an x, which is 2x, and a 14 plus 2, 16. Okay? From here, we just continue solving. Now we have only one variable, so we can find it. So what would I do from here? Divide by 2. And so x would equal what? 8. That's why this is called elimination, is because we are eliminating one of the variables. So that we have a new equation with just one variable that we can actually solve. Okay? Now what we're going to do is similar to what we did at the end of substitution. We are going to take that variable that we found, x equals 8, and we're going to plug it back in to one of the original equations. It doesn't matter which one you choose.
Will you get the same answer?
You will get the same answer. I'm going to pick the first one because it's positive. So it would be x plus y equals 14. So I'm going to plug in 8 for x. So 8 plus y equals 14.
It doesn't matter which equation you pick to plug.
Nope. Yep, you'll get the same answer. We're going to subtract 8. And we get y equals what? 6.
And then you do your permanent thing.
Yep, and then you make it as a point. So it's 8, 6. If you look at letter B, do I have any coefficients that are the same but opposite signs? No, I don't. And so the x's don't cancel easily, and the y's also don't cancel easily. And so that makes this problem more complicated, okay? And so what we have to do is what that little asterisk said under number 1. We have to manipulate with multiplication to make one of the variables have a positive and a negative of the same number, okay? A positive and a negative of the same number. And so I see when we have to do this, it's best to look for a coefficient of 1 if possible. So do you see how I have a 1x? 1x's are, or 1y's, are very easy to manipulate and are usually your best bet. So with that 1x, I need that x to be a negative 3.
So you multiply by 2.
So we're going to multiply by negative 3 because I need the x's to cancel. Yes, ma'am.
You always multiply by like the reciprocal.
Yes, you always multiply by the opposite. And so when I multiply by negative 3, though, I can't just multiply the x by negative 3, okay? I have to multiply the whole equation by negative 3 because it has to stay balanced. So I'm going to multiply this whole equation by negative 3. When I do that, nothing changes with the first equation. It stays the same. So we're just going to rewrite it off to the right. 3x plus 2y equals 8. But the second equation, every single thing gets multiplied by negative 3. So x times negative 3 is negative 3x. 3y times negative 3 is negative 9y. And 12 times negative 3 is negative 36. So now we have a negative or a positive 3x and a negative 3x. So we can now eliminate. So we're going to add our little line and our plus sign and make it look like we're adding. The x's cancel. And then we add the y's, add the numbers. So 2y minus 9y would be what? Negative 7y. And what would 8 minus 36 be? Good, negative 28. So now I have an equation that just has one variable, which is my goal. So I can find the variable. So what would I do now?
Divide this negative 7.
Now let's talk about this, just a little caveat. I'm noticing a lot of the same mistake on tests and quizzes. When I am dividing a negative by a negative, what kind of answer do I get? A positive. I see a lot of people either leaving it as negative, or like they'll just put the negative with one, the numerator or the denominator, or something weird. So negative divided by negative is positive. And so negative 28 divided by negative 7 would be what? 4. Positive 4. And so I have my y value. Now I'm going to take so now we're going to take y and we're going to plug it in to an original equation. It does not matter which one we pick. Does not matter. Which one do y'all want to do? The first one or the second one? Okay. So we would have x plus 3 times y, which is 4. So 3 times 4 equals 12. The second one. What is 3 times 4? 12. And then would I subtract this 12? Yep. And what happens? Good. Is x allowed to be 0? Yes, it is. Don't be scared of the zeros. It is totally allowed. Okay. So my answer is 0, 4. Now let's talk about 0, 4. If I was to talk about 0, 4 on a graph, what would that be?
Just a 4 on the left.
0.
0 up 4. And so what kind of point would it be? What would the vocabulary word for that point be?
Oh, like the like for
Mm-mm.
no. 0.
So if it's at 0 up 4, it's where the graph crosses what? The y-axis. It's where the graph crosses the y-axis. So it is the y-intercept.
Wait, how's that?
So this last one, I want you guys to just look at it for a minute and decide what you want to do. Do you want to cancel the x's or cancel the y's? Okay, if you want to cancel the x's, what do you need to do? Multiply which equation by 5? By negative 5. Good. We'll multiply by negative 5. We want to multiply by negative 5 because we want the x's to be opposite so they cancel. If I just multiply by 5, I would get 5x plus 5x, which is 10x.
If it was
A negative.
just multiply by the positive.
Yep. So we've got 5x plus 4y equals 36. So we just rewrite the first one. And then the second one, we multiply every single thing by negative 5. So I have negative 5x minus what? 30y equals negative 10. Now my x's cancel. I have 4 minus 30y, which would be what?
Negative 26.
Good, negative 26y. And then I have 36 minus 10, which is what? 26. Oh, convenient. Now what do I do?
Divide by negative.
Divide by negative 26. Y is equal to negative 1. Good. Now, what do I do with y? Plug it back into the original equation. Does it matter which one I choose? No. Which one do you guys want to do? The bottom one. Why did you choose the bottom one?
Because it has like
It has smaller numbers? Yeah, it has smaller numbers. That's what I normally do too. But if you don't want to and you choose the first one every single time, that's fine.
So when you're plugging in, you plug it in by the original, not the like multiplied version?
Exactly. And the reason why is because the original is always going to be correct.
Yeah.
And so it's just a good habit to get into adding, plugging into the original. So I have x minus 6 equals 2. So did you guys get x equals 8?
Yeah.
So my answer is 8, comma, negative 1.